welcome to the Court of the Edijester. I hope you're all well. I've got something different for you today, something that may be of import and interest. As I thought, when I read it, I thought, well, hello, this, we might get this out to the masses. As you lot watching, all 500 of you. You are officially the masses. Before we start, come be a warrior teacher in November. We need far more applications. It's a bit slow this time of year, but please do come and join us. Yeah, come and have a ball, because we do. Had a great session last night, actually, thinking about it. Brilliant. Session 2, in which we argue about a film. It's really good. I'll see you later, says he to them. I hope you enjoyed it. And they all go off. Wonderful. So, a few months, well, it's not months, actually. It must be a couple of years ago now. I went to see a woman called Gina Rippon speak at the University of Manchester. Now, Gina Rippon is Professor Emeritus of Cognitive Neuroimaging at Aston University. And the speech was about, the lecture was about differences in a male and female brains, which is something that's come up in our movement and regarding trans gobbledygook a number of times. So I thought that'd be interesting to go and see. So I did go and see it, and I met Gina afterwards. I had lots of questions, and I could have spent hours talking to her, but unfortunately it wasn't possible. She was being mobbed by everybody else. She's a marvellous woman. For some reason, reminded me of Mary Berry. I don't know why. Diminutive. Stylish, confident. That's what it was, I think. Anyway, so Gina published this yesterday about the differences in the brain. And I looked at it, I thought, ooh, I read it, and I thought, well, it's lacking a kind of infogram to explain it a bit better. And so I messaged Gina on Twitter saying, needs an infogram. And 2 minutes later, there it was. So thank you for that, Gina. So here's what she had to say. In the last 10 years, some 20,000 or so academic papers have been published on the neuroscience of sex and gender. Perhaps you've read the media coverage of such papers suggesting there's finally proof that stereotypical abilities such as men being good at reading maps or women excelling at nurturing can be pinpointed in the brain. Interesting. You missed a trick there, Gina. You so could have done the Victoria Wood thing there, couldn't you? Women can't read maps and men can't get interested in headboards. That would have been perfect outro, I think. Given the sheer quantity of output in this area, how can you tell what is really groundbreaking research and what is an over-enthusiastic application of hype? Misleading spin is often blamed on university PR teams, non-specialist science writers in mainstream newspapers or social media. But the source of deceptive impression may sometimes be the research papers themselves. This is interesting because we were recently teaching on the Warrior Teacher Mindset about anti-science and pseudoscience. So this was particularly interesting to me. For example, researchers may hyper-focus on a limited set of findings. They may fail to report that many of the differences they were looking for didn't make the statistical cut, or they may be less than cautious in discussing the impact of their findings. Just as much as researchers need to be meticulous about the best methodology and the most powerful statistics, they need to manage the impressions they make when communicating their research. And if they don't, then the interested but non-expert reader may need help to spot this. That's, really interesting because it's about science communication is what Gina's essentially talking about here. So magic, spotting the spin. My colleague and I recently published a set of guidelines which offer just such assistance, identifying 5 sources of potential misrepresentation to look out for. The initials helpfully form the acronym MAGIC, which is short for magnitude, accuracy, generalizability, inflation, and credibility. For magnitude, the question is the extent of any differences clearly and accurately described? Take this 2015 study on sex differences in the human brain. It reported on 34,716 different patterns of functional brain connectivity and found statistical differences between females and males in 178 of them. Yet, given that less than 0.5% of all possible differences they were measuring actually turned out to be statistically significant, they wouldn't really be justified in reporting sex differences as prominent. In this study, they weren't. So, the magnitude, you're looking at the size of it. What exactly happened? What was the sample? What was the size of it? So the first clue there to looking carefully at information. The next question is to do with accuracy. Are the techniques and variables clearly defined and carefully used in the interpretation of results? It should be really clear how the study was run, what measures were taken, and why. For example, a recent paper suggesting that the COVID lockdown effects had a more pronounced effect on adolescents' girls' brain structure than boys fell at this hurdle. The abstract referred to longitudinal measures, and much of the narrative was couched in longitudinal pre- and post-COVID terms. Longitudinal studies, which follow the same group of people over time, are great as they can discover crucial changes in them. But if you peer closely at the paper, it emerges that the pre- and post-COVID lockdown comparisons appear to be between two different samples, admittedly selected from an ongoing longitudinal study. Nonetheless, it is not clear that like was compared with like. Do you get it? So it's almost like they're looking for the answer and they take what they need. Fascinating, right? Okay. The third question has to do with generalizability. That's a great word. Are authors cautious about how widely the results might be applied? Here we encounter the problem with many scientific studies being carried out on carefully selected and screened group participants, sometimes just their own students. Care should be taken to ensure that this is clear to the reader, who shouldn't be left with the impression that one or more sets of participants can be taken to be fully representative of, say, all females or all males. If all study participants are selected from the same single community, then referring to hundreds of millions of people in interpreting the relevance of the result is something of an overstatement. So again, here, this idea of generalizability. Has there been a generalizing of the original people that were involved? Has there been a generalizing? The fourth category, inflation, is to do whether the authors avoid language that overstates the importance of their results. Terms such as profound and fundamental may be misplaced, for instance. Remember, James Watson and Francis Crick merely described their discovery of DNA's double helix structure as of considerable biological interest. I think that Francis Crick and James Watson were masters of the understatement. I mean, if ever there was anything that needed to be said as profound and fundamental, I think that DNA double helix might be one. Finally, we should consider credibility, very important. Are authors careful to acknowledge how their findings do or do not fit with the existing research? Authors should be upfront about alternative explanations for their findings or suggest other factors that might need to be investigated in further studies. Suppose, for example, they are looking at the allegedly robust sex differences in visuospatial skills, right? Which include things like visual perception and spatial awareness. Have the authors acknowledged research suggesting that the amount of time people spend on practicing the skill, such as when playing video games, has been shown to be more significant than biological sex in determining such differences? So credibility is looking to see if there are other variables, or is there something else that could, in fact, impact on it? If gamers are more likely to be boys, that doesn't necessarily mean their brains are wired for them. It could equally well be reflecting gendered pressures that make such games a popular, culturally comfortable pastime among boys. The focus of these guidelines is on sex, gender, brain imaging studies, but they could well be applied to other areas of research. Post-lockdown surveys have suggested that the public has greater trust in what scientists are saying than they did before the pandemic. Scientists need to be careful that they retain that trust by ensuring that what they report is unambiguous and free from hype. Hopefully the magic guidelines will help them and their editors achieve this. If they don't, then eagle-eyed readers, magically armed, will be on their guard. Right? Okay, so what we've got here is a really interesting artifact that's been created, I think, at a time when the public's ability to spot bullshit is going to be at an all-time high. And it doesn't just, thank you, Gina, by the way, and it doesn't just apply to science. It applies to all sorts of things. As you saw when I read out that ridiculous article yesterday and discussed what was hidden within it about the fact that there are trans children, which there aren't, and paraphilic children, which there aren't. So go and have a read of this, go and have a look and go and have a mull and see what you think. Other than that, I think this is just something worth chewing over. So I hope you will give it some time to do so. I'm going to do that, and I'll see you later. All right. Ta-da, folks. Thanks for listening.